I'm Anil Kumar. Welcome to my series on solving previous test papers. I hope these questions which I'm taking up will help you in getting good marks. So here are 11 questions from previous test papers on combinations. Question number 1. A flower shop offers a selection of 4 roses, 6 petunias and 5 pansies. In how many ways can you select a bouquet consisting of 2 different petunias, 3 different pansies and 2 different roses? Question number 2. Mr. Anil has to drive 12 players to soccer practice. He drives them all in 4 trips, taking 3 at a time. In how many ways can the passengers be chosen? Question number 3. A Boy Scout troop has 14 members made up of 5 12-year-olds, 3 11-year-olds and 6 10-year-olds. In how many different ways can the leader appoint 3 members to clean up camp if there are no restrictions, if there is exactly two 12 years old and 1 10 years old, and C is if there is at least 1 11-year-old. So you can actually copy these questions, answer them and then check with my solutions. Question number 4. 1 freshman, 3 sophomores, 4 juniors and 6 seniors apply for 5 positions on honor council. In how many ways can council be selected if the council must have at least 1 senior or 2 sophomores? Question number 5. At a family reunion, everyone greets each other with a kiss. If there are 20 people at the reunion, how many different kisses takes place? Question number 6. In how many ways can 5 pets be chosen from 8 dogs, 6 cats and 7 bunnies if there must be at least 2 dogs? Question number 7. A poker hand consists of 5 cards dealt from a standard deck of 52 cards. How many different poker hands are possible if the hands contain at least 2 red cards and B is exactly 1 pair? Question number 8. Peter has 10 pictures of family and 8 pictures of friends to put on his wall. He decides to arrange 4 of the family pictures and 3 of the friends' pictures. In how many ways can he arrange them? Question number 9. There are 5 north-south and 3 east-west roads from my house to the campsite. How many ways are there to reach the campsite if I travel only north and south from my house? Question number 10. In how many ways can a committee with at least 1 member be appointed from a board with 10 members? And here is the last question, which is if PNR equals to 506 and CNR is 253, find N and R. So I hope you already have a copy of these questions. Try them out and then check with my solution. So let's begin with solving the last question. So we'll get the formulas of permutation and combination also, which will help us in solving the first 10 questions. Question number 11, we are given PNR is 506. So PNR means n factorial divided by n minus r factorial. This is given to us as 506. And CNR is given to us as CNR is basically PNR by R factorial. So I could write this as n factorial n minus R factorial times R factorial is given to us as 253. So we need to find n and R. So if let's number these equations. Let's say this is our equation number 1 and this is our equation number 2. Now, if I divide one equation by the other, what do I get? Or you can say, if I substitute n factorial over n minus R factorial by 506 in this equation, what do I get? So either way, you could solve it, correct? Solve for R factorial first. That's the whole idea. So what we will do here is we could divide equation 1 by equation 2. So when you divide n over n minus R factorial, n over n minus R factorial will get cancelled. You get 506 over 253, correct? So what we get here is n factorial divided by n minus R factorial. So we are dividing the whole thing by this term, which is n factorial divided by n minus R factorial times R factorial. And what we get this is 506 over 253. Now here clearly it is equals to R factorial, right? So we get R factorial equals to 2. And that gives you the value of R as equal to 2. Correct? So we have found the value of R by dividing one equation by the other. You could have also done substitution to get the same result, right? Now since we know R, we can use one of these equations and find n. So let's substitute R equals to 2 in the first equation. So we get n factorial, let me do it in a different thing, n factorial divided by n minus 2 factorial equals to 506, correct? So what we did is we sub R equals to 2 in equation 1. Now what is n factorial? N factorial means n times n minus 1 times n minus 2 factorial. And that divided by n minus 2 factorial gives us 506. Now the factorial parts cancel. So we have n square minus n equals to 506 is a quadratic equation. Bringing 506 to the left side, we could solve this equation, correct? So now we are looking for product of two numbers to be 506 and the sum minus 1. So that means the two numbers are very close, correct? So easy way is, let's find square root of 506. So if you do square root of 506, you get 22 times 4, 9. That means the two numbers are 22 and 23, right? So if you do 22 times 23, you get 506 and their difference is 1, correct? So we could factor this, right? So we could write this as bigger number is negative, so n minus 23 times n plus 22 equals to 0. Now we know that n is greater than 0, so the only answer possible is n equals to 23, right? So this gives you a valid answer, which is n equals to 23. So n minus 23 equals to 0 means n equals to 23. So we get our answer as n equals to 23. So our answer is n equals to 23 and r equals to 2. So I hope the steps are absolutely clear, and we also understand that we're taking permutations when order is important and combination when order is not important. So basically we know that we could also write NCR equals to NPR divided by R factorial, correct? So that is what these formulas are. And now let's begin with question number 1. Question number 1. A flower shop offers a selection of 4 roses, 6 petunias and 5 pansies. In how many ways can you select a bouquet consisting of 2 different petunias? So we have to select 2 petunias from 6, 3 different pansies which come from 5, and 2 different roses which come from 4, correct? So that is the question. So let's look into this. It's a clear case of combinations, and we want 2 different pansies, 3 different petunias, 3 different pansies and 2 different roses. So the combinations are 2 different petunias, they come from 6 petunias. So out of 6 we have to get 2 of them, right? Times 3 different pansies. These pansies are from 5 pansies. So from 5 pansies select 3. 2 different roses from 4 roses, right? So from 4 roses select 2. So that becomes your answer, correct? So you could actually just multiply these terms and get your answer. So we have 6 C2 times 5C3. So we'll use calculator, but these questions could be done without calculator also. Some of them. Okay, wait. So we have 4C2. So 4C2 equals to 900. So the answer is 900. So that is the first answer. Now the second question here is, Mr. Anil has to drive 12 players to soccer practice. He drives them all in 4 trips. So we have 4 different trips, taking 3 at a time. In how many ways can the passengers be chosen? So in the first trip, we could choose 3 from 12, right? So we could choose 3 from 12. Now, since we have taken 3, we are left with 9. So from balance 9, we could choose another 3. And then from balance 6, we choose 3. And then from balance 3, we take 3. So that becomes the answer. Clear? So that is how you're going to answer this. So we have 12C3 times 9C3 times 6C3 and times 1, we can say, equals to 369,600. Right? So that is how you could answer these 2 questions. So I hope the concept is clear, right? So let's move on and see question number 3. Question number 3. A Boy Scouts troop has 14 members made up of 5 12-year-olds, 3 11-year-olds, and 6 10-year-olds. In how many different ways can the leaders appoint 3 members to clean up camp if there are no restrictions? So that is 14C3, correct? So 14C3 is the answer for first one. You need to select 3 out of 14. Now the second one, part B, is if there is exactly 2 12 years old and 1 10-year-old. So these 2 12-year-old are being selected from how many 12-year-olds? 5 12-year-olds. You get the idea, right? So this is being selected from 5 12-year-olds. You select 2. And means multiply one 10-year-old. And there are 6 10-year-olds, correct? So multiplied by 6C1. So that gives you the answer, correct? Which is 10 times 6, which is equal to 60, correct? So that is how you're going to answer this. Part C is, if we are selecting 3 such that there is at least one 11-year-old, right? So when we say at least one 11-year-old, we could think like this. We say total, take away no 11-year-old. Right? So in our case, total is 14C3. And from this, we want to select all 3, not from 11. So in 11, there are 3 11-year-olds, right? So what we want to do here is that we want to take So if I take away 3 from 14, that means 14 minus 3 will give us 11, right? So 11 are not from 11-year-old. You get an idea, right? So from these 11, we are going to select 3. So it will be 11C3. So that will be our answer, correct? So that is how we can get both the answers. So now let's calculate 14C3. So 14 shift combination 3 is equal to 364. First answer is 364. So here we get 364 minus 11C3. So 11 shift C3, which is equal to 199. So there are 199 choices. So I hope that is absolutely clear. Let's move on and do the next question. Question 4. 1 freshman, 3 sophomores, 4 juniors and 6 seniors apply for 5 positions on an honor council. In how many ways can council be selected if the council must have at least 1 senior or 2 sophomores, right? So let's count the total number of persons. We have 1 freshman, so 1 freshman plus 3 sophomores, 4 juniors, 6 seniors. So in all, 1 plus 3, 4, 4, 8, plus 6, 14. Right? We want to select. In how many ways can council be selected if the council must have at least 1 senior or, so there's or condition, and they are applying for 5 positions. So we have 5 positions. And the 2 conditions given to us are with or at least 1 senior. We want at least 1 senior, or means we'll add 2 sophomores. Okay, so that is what we need. So to find out at least 1 senior, what we can find is that we can calculate total combinations, and from that we take away the ones without senior. Since there are 14 in all and we need to take 5 positions, so 14 C5 minus without senior means there are 6 seniors, so 11 are left, right? So 14 minus 6 seniors. So we are left with 8, right? So 4 plus 4, 8 are left. And now out of those 8, we have to select 5. So 8C5. So that becomes this combination. Plus 2 sophomores out of how many? We have 3. So from 3, we select 2. Total, we need to select 5. So 3 are left. So 3 are selected from rest 11, right? 14 minus 3. We are selecting 3. So that is all. So that is the combination which we get. So let's calculate this answer now. So what we have here is 14C5 minus 8C5 plus 3C2 times 11C3, which is equal to 2441. So that becomes the answer. You get an idea. So just do this combination. So you get the answer as 2441. Now let's move on and take question number 5. At a family reunion, everyone greets each other with a kiss. If there are 20 people at the reunion, how many different kisses takes place? So there are 2 people, so it will be 20C2. So that will be the answer. So let's calculate this, 20C2. 20C2 equals to 190. 190. Question number 6. In how many ways can 5 pets be chosen from 8 dogs, 6 cats and 5 bunnies? So we are taking 5 from 8 dogs, 6 cats and 7 bunnies. So find the total. So total is 7 plus 6, 13 and 8, 21. Right? So 21 is the total in this particular case. Now it says, in how many ways can 5 pets be chosen if there must be at least 2 dogs, right? So at least 2 dogs from 5 pets. So what we could do, we could adopt different ways of solving this. So when we say at least 2 dogs, we could also consider a case that we select no dogs or we select 1 dog. And we take this away from total number of selections, right? So that could be one way of doing it. The other way is there are 5 selections, right? So in 5 selections, we could have 2 dogs, 3 dogs, 4 dogs, or 5 dogs, right? So that could be another way of doing it, right? So there are actually, as far as the dogs are concerned, there are 8 dogs, and the other animals are 6 plus 7, 13. So we have combination of 8 and 13. So either way you can do it. So let me write them down. So it says at least 2 dogs. So we want to do at least 2 dogs. So you could select 2 dogs. So that means from 8 you select 2 dogs. In that case, since you want to make 5 pets, 3 are selected from 13, right? So 13C3, you get an idea, right? So that becomes one combination. If you select 3 dogs from 8, in that case you make selection of 2 from 13. You could select 4 dogs. In that case from 13, you select 1, and then you could select all 5 dogs. So from 8, you could select 5 dogs. So that is one way of doing it. You can just add this up. So let's calculate this. So we get 8C2 times 13C3 plus 8C3 times 13C2 plus 8C4 times 13C1 plus 8C5 equals to 13342. So these are the total possibilities, correct? Question number 7. A poker hand consists of 5 cards dealt from a standard deck of 52 cards. How many different poker hands are possible if the hand contains at least 2 red cards? That's one. Second is exactly one pair. Okay, so let's do the first one, which is at least 2 red cards. We'll follow indirect method so we can find total combinations, right? Since we are dealing 52 and we need 5, so this will be 52C5, that is the total. From the total, we should take away the hands which do not have 2 or more red cards. That means which has either no red cards or they have 1 red card, right? So take away no red card and also take away 1 red out of 5, right? So these are the 2 combinations which we need to take away, correct? So if there are no red cards, in that case, from 26 red cards, we select none, but all the 5 we select from the other 26, right? So from other 26, that makes us 52, we make selection of 5. For 1 red card, from 26 red cards, we select 1 and 4 are selected from the other 26, right? So that is what it is, 26, correct? So that gives you the answer. So let's calculate this out. So if we have 52C5, take away 26C0 times 26C5, take away 26C1 times 26C4. And that gives you the answer as equal to 214480. So that becomes the answer for part A. Now let's look into the second part, which is exactly one pair. Now one pair means in a deck we have 13 different cards, right? So one pair out of 13 numbers, right? You could say numbers or whatever. So that is what you have. So that means that takes care of 2. And now we have 3 more because there are 5 cards. Now these 3 are not from the pair which we have taken. So out of 12, we need to select 3. And these 3 could be of 4 different types. They could be spades, hearts, diamonds, or clubs. You get an idea, right? So that is what we are looking into. So we have a pair, that means we are selecting 2 of one kind from a pair, and now these could be 13 of them, correct? So there are 4 of each card, right? So basically there are 13 cards, so 13 times. Out of 4 we select 2, because each type has 4 cards, right? We could have ace, 2 aces, 2 kings, 2 queens. So those are those 13 numbers. And if we are having 2 aces, they are selected from 4 aces. That is what it means. So we made selection of these 2. Now for the rest 3, if let us say we have selected ace, we have option of other 12. So from those 12, we make selection of 3. But in this case, we have 4 types times 4. You get an idea. So these are the total number of combinations. So let's multiply and get them. So we get 13 times. Rather, what I will do here is that we'll first calculate the combinations, then multiply by 52, right? So we have 4C2 times 12C3 let's calculate this, and we'll multiply this by 13 times 4, which gives us 68640. Right, so that is how we are going to solve it. So I hope that steps are clear. So the idea here is that pair could be of ace, that is 1, 2, 3, 4, up to 10, or jack, queen, or king. So these are 13 in all, correct? So we could have pair, and each is, there are 4 of each type. So 4C2. Once you select these 2, the other 3 could be selected from the rest 12, right? And since we have colors, right? So we got hearts, spades, diamonds, and clubs. That gives you 4. So I hope that is clear. It's kind of tricky question, but I hope the concept is clear. Now let's move on and take a solution for question number 8. Question 8. Peter has 10 pictures of family and 8 pictures of friends to put on his wall. He decides to arrange 4 of the family and 3 of the friends' pictures. In how many ways can he arrange? So we are selecting from 10 pictures of family, he is selecting 4, right? So that means 10C4. This is of family. Times from 8 pictures of friends, 3 friends. So that means 8C3. This is friends. So in all, we get 7 pictures. Now, once you have these 7 pictures, to place them on a wall, there are 7 factorial ways, right? You could place any one of them first and order them. So now that order is 7 factorial. So that is how you're going to calculate this answer. So the answer here is 10C4. It is 10C4 times 8C3 times 7 factorial, which gives us a very big number, which is 592,400. So that is how you're going to calculate this answer. I hope the steps are clear. We're almost at the end. Last 2 questions. 9. There are 5 north-south and 3 east-west roads. So that means 1, 2, 3, 4, and 5. And there are 3 east-west roads. Let's say like this. 1, 2, and 3. From my house to the campsite. How many ways are there to reach the campsite if I travel only north and east? Okay, so let's assume that we are traveling north and east. So let's say we start from here. We are traveling north and east. We want to reach that side. You get an idea. So we could travel 1, 2 spaces here, so 2, and this side we say 1, 2, 3, 4, 4. So in all there are 6 places to move, right? So that gives us 6 factorial, and out of these 2 are same, so it is 2 factorial times these are also repeated, 4 factorial. So that becomes the solution for the given question, correct? So 6 factorial divided by 2 factorial times 4 factorial. So 6 factorial equals to, we'll divide this by 2 and then we'll divide this by 4 factorial, which gives us 15. So the answer is 15. Question number 10. In how many ways can a committee with at least 1 member be appointed from a board with 10 members? So it could be like committee with 1 member, 2 member, or whatever. So total combinations with 10 members should be 2 to the power of 10 minus 1. So because for every member we have 2 choices. We may select a member or we may not select a member. There is one combination which is not selecting any member, that will be subtracted, right? So this is no member, 0 selection, or no member. So that gives you the answer 1024 minus 1, which is 1023. We had already done question number 11. So that brings us to the end of this solution of a set of questions from previous test papers. I hope that helps. Feel free to write your comments and share your views. And we'll be uploading a few more similar test papers. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.